Welcome back. We have traveled through the structural world of solids and we have explored the rebellious, life-saving behavior of liquids. Now, it is time to step into the third most energetic state of matter, gases. If we heat a gas, does it expand? The answer is a capital yes. In fact, gases don't just expand. They are the absolute superstars of thermal expansion. They expand far faster and far greater than solids and liquids combined. Why? Because just like everything else, a gas is made up of tiny particles. But unlike solids and liquids where particles are tightly locked or closely held, gas particles are completely free. When they catch heat energy, they don't just gently vibrate. They fly apart wildly, demanding immense space. And because gases take the shape and size of whatever space they are given, they don't have a fixed length or a flat surface. So, just like liquids, we completely throw out linear and superficial expansivity. We only care about one thing: how their entire three-dimensional volume responds to heat. But wait, there is a fascinating catch when it comes to gases, a catch that is physically impossible to pull off with a solid or a liquid. It is entirely possible to heat up a gas, skyrocket its temperature, and yet its volume does not increase by even a single cubic millimeter. How is this possible? Because gas particles are so free, we can physically trap them. Imagine putting a gas inside a rock-solid, completely sealed metal container with a heavy locked lid. There is absolutely no room for expansion. When we turn up the heat, those trapped particles absorb the energy. Their kinetic energy goes through the roof, and they desperately try to rush away from each other. But with nowhere to run, their volume cannot budge. Instead, they begin to furiously slam into the rigid walls of the container at a terrifying speed. So, if the container doesn't expand, what happens next? This is where physics gets beautiful. As these energetic particles bombard the rigid walls at a faster and harder rate, their rate of change of momentum skyrockets. If we look back at Newton's second law of motion, an increased rate of change of momentum directly creates a massive increase in physical force. The force hitting the walls has risen. Now, think about our basic formula for pressure. Pressure equals force divided by area. In our sealed container, the surface area is completely fixed. It cannot change, but the force inside is growing larger by the second. If force goes up while the area stays the same, it means one inevitable thing: the internal pressure has dramatically increased. What is the grand conclusion here? When you heat a gas, it faces a crossroads. If it is free, its volume will expand. But if its volume is locked down, its pressure will explode upward instead. Because of this dual nature, the scientific world realized that we cannot study the thermal expansion of gases using just one simple rule. An increase in a gas's temperature can lead to two entirely different outcomes: an increase in its volume or a massive buildup in its pressure. Therefore, our study of gases splits into two magnificent parts. Path number one looks at what happens when pressure is kept constant, allowing the volume to expand freely, which leads us right back to cubic expansivity. Path number two looks at what happens when the volume is kept locked and constant, causing the pressure to change with temperature. In physics, we formally call this second path the pressure law. These are the two foundational pillars that govern the invisible energetic world of gas expansion. You experience this incredible physics all around you without even realizing it. In its static, trapped form, we see it when a car tire gets overly stiff on a blistering hot afternoon, or an aerosol spray can heats up, forcing internal pressure to dangerous limits. But let's look at something every adult and child enjoys every single day: the modern automobile. Have you ever wondered what actually moves a giant car down the road? It is the sheer beauty of gas expansion. Inside the car engine cylinder, a tiny mist of fuel is ignited. This creates an immediate, massive explosion of hot gas. As the temperature instantly spikes, the gas desperately tries to expand. Because it is trapped inside a solid cylinder, it unleashes an immense thermal expansion force against the only thing that can move, the piston. This expanding gas violently shoves the piston down, which turns the heavy crankshaft, spins the wheels, and sends the vehicle gliding smoothly down the highway. The very car you ride in is literally powered by the thermal expansion of gases. Thank you so much for joining our introductory lesson on the thermal expansion of gases. To make sure you never miss a single step as we break down these gas laws, make sure to like this video, subscribe, and follow the Udimking Education Foundation on our official WhatsApp channel and social media networks. Stay curious, keep learning, and I will see you in our next lesson.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.